So here is another question on simple harmonic motion. So it is given that a particle executes simple harmonic motion with a time period of 2 seconds and amplitude 5 centimeter. Find the displacement, velocity and acceleration after 1 by 3 second starting from the mean position. So first, as we do in all the we have did in all the questions related to SHM, first we have to write the basic format of SHM equation, that is x is equal to a sine omega t plus phi. Okay, a is amplitude, omega is the angular frequency, t is the time instant, particular time instant, and phi is the initial phase. Here it has been given that the particle starts from the mean position, that is the equilibrium position. So the initial phase angle phi is equal to 0 radian. So this equation becomes x is equal to a sine omega t. Now it is given that the amplitude a is equal to 5 centimeters, which means if this is the equilibrium position, it can go to the right 5 centimeters and also to the left 5 centimeters. Okay, this is the equilibrium position. Okay, like this. So time period t is equal to 2 seconds. Now we know omega, which is equal to 2 pi f or 2 pi by t, okay, this much. So that is equal to 2 pi by t is equal to 2, so that is equal to pi. So omega is equal to pi radians per second. So now the SHM equation is substituting these values. X is equal to a, which is 5 sine pi t, this much. Now we have to find the displacement, velocity and acceleration after 1 by 3 second, which means we have to substitute t with 1 by 3 seconds, this. So the displacement at t equals to 1 by 3 seconds, that is equal to 5 sine pi, place of t will multiply 1 by 3, so it becomes 5 sine pi by 3. So it is equal to 5 into root 3 by 2, this much. So it is coming around 4.33 centimeters. Okay, so the displacement at t equals to 1 by 3 seconds is equal to 4.3 centimeters. Okay, this. Then we have to calculate the velocity. Now velocity v 1 by 3 seconds, that is equal to dx by dt, which is equal to 5 pi cos pi by 3. That I have substituted the value t equals to 1 by 3. How it happened? We know x is equal to a sine omega t, so velocity, that is dx by dt, becomes omega a cos omega t. Okay, omega is equal to pi, t is equal to 1 by 3. Again omega is equal to pi and a is 5, so this becomes 5 pi cos phi by 3. So this becomes cos 60 degree 1 by 2 by 3.14. So if you put the value, it is coming around 7.85 centimeters per second. Okay, So this is the velocity equal to dx by dt. X is equal to a sine omega t. Okay, this omega a cos omega t, we have just put the values. Omega equals to pi, a is equal to 5 cos omega t, which is cos pi by 3 at t equals to 1 by 3 seconds. So the velocity at t equals to 1 by 3 seconds is equal to 7.85 centimeters per second. Then the acceleration. Again, acceleration is equal to dv by dt or d square x by dt square. So this will be again dv by dt. If we do it, so it becomes minus omega square a sine omega t. So if we only stick with the magnitude, it will be omega square a sine omega t. So this will become the acceleration at t equals to 1 by 3 seconds is equal to omega square, that is pi square a, which is 5 sine omega t, that is sine pi by 3. So that is equal to, if we calculate, it is coming around 42.6, if we round it off, it is 42.77 centimeters per second square. So this is the acceleration. Okay, this much. So this is a very basic question related to SHM displacement equation, which asks us to determine displacement we have already calculated, but velocity and acceleration at a particular time instant. Okay, so this is the thing. So here is another question on simple harmonic motion. So it is given that the shortest distance traveled by a particle executing SHM from mean position in 2 seconds is equal to root 3 by 2 times its amplitude. Determine its time period. Okay, so let's first write the basic SHM equation format. So basic SHM equation format, the displacement equation is a sine omega t plus phi. Okay, now it has been given that this particle is executing SHM from mean position, so from the equilibrium position at t equals to 0. So initial phase is equal to 0 radian. Now here this equation, it becomes x is equal to a sine omega t. So here it has been given that in 2 seconds, that is t equal to 2 seconds, this instantaneous displacement x is equal to root 3 by 2 times the amplitude, that is small a, this. So at t equals to 2 seconds, okay, x is equal to root 3 by 2a, so that is equal to a sine, in place of t I am writing 2, I am substituting 2, sine 2 omega. Okay, this. So that implies sine 2 omega is equal to root 3 by 2. Okay, root 3 by 2. So we have to come up with a sine function whose value is root 3 by 2 in order to equate the left hand side and the right hand side. So that is equal to sine 60 degrees, sine root 3 by 2, yes, sine pi by 3, sine pi by 3, that much in terms of radians. Okay, that is in terms of degrees, this is I am writing in terms of radians. So that implies 2 omega is equal to pi by 3. Okay, that implies omega is equal to pi by 6 radians per second. Okay, so now we know that omega is equal to pi by 6 radians per second. We know omega is equal to 2 pi f, where f is the frequency in hertz, is equal to, or second inverse, and this is equal to 2 pi by capital T, which is the time period. So 2 pi by T is equal to pi by 6. That implies T is equal to 12 seconds. 2 into 6, that is T is equal to 12 seconds. That is the time period which was asked, to calculate the time period of the above simple harmonic motion. Okay, so this is the thing.